Hello students, welcome you all on this YouTube channel. You're most welcome. This question has been asked in your Engineering Services 2020 examination. Let us solve this question. First, let me read the question statement for you. Question statement is like a DC shunt generator supplies a load of 7.5 kilowatts at 200 volts. If the armature resistance is 0.6 ohm and the field resistance is 80 ohm, then calculate the induced EMF. Right? Out of A, B, C, D, only one option is correct that we have to choose after solving this numerical. So, have you understood the question? Let me repeat the question once again. A DC shunt generator supplies a load of 7.5 kilowatts at 200 volts. If the armature resistance is 0.6 ohm and the field resistance is 80 ohm, then calculate the induced EMF. So you have to calculate the induced EMF out of ABCD. Only one option is correct that you have to choose after solving this numerical. So you have to calculate the armature induced EMF. Alright. So let me first draw the circuit diagram of DC shunt generator. Right. So this circle represents the armature, right? Here across this armature terminals, the field winding is shunted because it is a DC shunt generator. So field winding is shunted across the armature terminals, alright, like this. Okay. So you know this, it is a DC shunt generator, right? Field winding is shunted across armature terminals. Here the load is connected, right, and this DC shunt generator is supplying a load of 7.5 kilowatt at 200 volts. So load power is 7.5 kilowatts, alright, and this generator is supplying this load of 7.5 kilowatt at 200 volts. It is given in the question, right? 7.5 kilowatt at 200 volts, right? So the voltage across the load terminals is 200 volts, right? So this voltage is basically 200 volts, right? So the load terminal voltage VT is 200 volts. VT is 200 volt. It is given in the question, right? VT is 200 volts. Generator is supplying this 7.5 kilowatt at 200 volts, right? Now across armature terminals, when this armature rotates in a stationary field, it will cut the stationary field lines. Induced EMF is developed in the armature, and that induced EMF that is developed is basically generated EMF because it is a generator. So let me denote it by E suffix G, right? EG. That is a generated EMF across this armature terminals, alright. And here this is the armature resistance. This is the armature resistance that is connected in series with this armature. So this is the armature resistance RA, and RA is given as 0.6 ohm, right? Armature resistance is 0.6 ohm and field resistance is given as 80 ohms, right? Shunt field resistance is given as it is given as 80 ohms, right? So Ra, that is the armature resistance is given as 0.6 ohm, right? And shunt field resistance, that is, let be denoted by RSH, it is given as 80 ohms. Alright, so now you have to calculate the induced EMF. So you have to simply see this from this armature terminals, armature current will flow like this. So this is the armature current. Armature current is flowing across this armature terminals. Alright. Okay. So this is the armature current which is flowing across this armature. Okay, this is the armature current, let me denote it by IA. Okay. Now simply apply Kirchhoff's voltage law in this loop and you will get, this is the shunt field current ISH. Alright, apply Kirchhoff's voltage law in this loop and you will find the generated EMF. So generated EMF is plus EG, right? Plus EG. Current flows in the direction of current flow, there is a voltage drop. So there is a voltage drop in this armature resistance which is represented by negative sign. So minus IARA, right? Okay. So this is plus and this is minus, that's a drop. So minus IAR, plus to minus IAR, and here again the current is flowing in the shunt field resistance which is ISH. In the direction of current flow there is a voltage drop, so later sign will be negative, so this is negative, right? This will be negative and this will be positive. So plus to minus ISH RSH. ISH RSH is equal to 0. If you apply KVL in this loop, then you will get plus EG plus to minus IARE, right? Plus to minus VT is equal to 0, or you can write EG is equal to VT plus IARE, right? So terminal voltage is given as 200 volts. It is given in the question. IA, now you see armature current is sum of these two current. Which two current? ISH, shunt field current, and this load current. Load current is IL. That right? So armature current is sum of these two current, ISH and IL, right? If you apply KCL, Kirchhoff's current law, at this particular node, then you will find armature current is sum of ISH and IL. So here this IA is ISH plus I load IL into RA. RA is 0.6. It is given in the question, right? So from here you can calculate the generated EMF, 200 volts, that is VT. ISH is shunt field current. Shunt field current is basically, this is VT by RSH, because field winding is directly shunted across armature terminal and the same field winding is directly shunted across the load terminals, because this is in parallel with this and this armature terminal is in parallel with this field current. All three are in parallel. So you can write ISH is equal to terminal voltage VT divided by shunt field resistance RSH. ISH current ISH, shunt field current ISH is equal to VT divided by IRSH. VT divided by RSH, right? So VT divided by RSH, alright. iLoad, for iLoad you can directly find out, this data, 7 power data, 7.5 kilowatt. So 7.5 kilowatt divided by 7.5 kilowatt means 7.5 into 10 to power 3 watts divided by voltage, terminal voltage, that is 200 volt, right? So that is a load current. P is equal to VI, simple relation. So I is equal to PYV. P is 7.5 kilowatt, V is 200 volt. So I is equal to PYV, that means 7.5 into 10 to power 3 divided by 200 into 0.6. So from here you will get VT is 200 volts, RSH is 80 ohms, okay. So plus 7500 divided by 200 volts into 0.6, or you can directly solve this. 200 by 80, it is 2.5 amperes, right? 7500 divided by 200, so 75 by 2 becomes 37.5, right? So 37.5, alright, and bracket closed, multiply by 0.6. So 200, so 37.5 plus 2.5 becomes 40 into 0.6 becomes 24. So 200 plus 24 becomes 224 volt is the answer. So this is your answer, right? So which option is correct? Tell me which option is correct. Option A is correct. Option A is correct. 224 is the generated EMF, or you can say induced EMF. So option A is correct. This is the correct option. So for all such kind of question, you can subscribe to this channel, right? Subscribe this channel for all such kind of GATE and engineering services questions. Thank you very much. Thanks for watching.